In this question, we're given that a matrix A has 36 elements. The question is how many possible orders are present. So if a matrix A is a M by N matrix, the number of elements in A is nothing but Mn, right? If A is a 2 by 3 matrix, it has 2 rows and 3 columns. So how many total elements are there? 2 into 3, which is equal to 6 elements. So now a matrix A has 36 elements. So how many different orders are present? It is nothing but in how many ways I can find two numbers M and N such that M into N is equal to 36. So if A is an M by N matrix, Mn has to be equal to 36. So how many different ways can the product of two numbers be equal to 36? This is a permutation and combination question about the number of factors. So the number of ways in which Mn is equal to 36 depends on number of factors. So number of factors depends on the prime factorization of 36. So 36 can be written as 2 square times 3 square, right? So the prime factorization is 2 square into 3 square. So what is the number of factors? Number of factors is each power has to be increased by 1 and multiplied. That's the formula. So 2 plus 1 times 2 plus 1. That is equal to 9 factors. The number is small, so you can directly calculate the factors. This is a standard process to find the number of factors. You have this formula in permutations and combinations. Now, what are the factors? 1, 2, 3, 4, 6, 9, 12, 18 and 36. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 9 factors. So now, if you take M into N is equal to 36, correspond to each of this factor, you can find, if you take these as M's, correspondingly you can find an N. So 1 by 36, 2 by 18, 3 by 12, 4 by 9, 6 by 6, 9 by 4, 12 by 3, 18 by 2 and 36 by 1. So these are the different possible orders. So how many orders are present? 9 different orders are possible. 9 different orders are possible. So that's the answer to this question. So next time, if you're given a different number, do the prime factorization. Whatever powers you have, add 1 to them and multiply, you get a number. So this number will be the answer to this question.